All right, I guess we'll get started. Sure, we'll get some people joining in the middle. Thank you for coming today. My name is Jed Deame. I'm with Nextera Video, and we're going to talk a little bit about IPMX. What the heck is it? How does it differ from 2110? Why do we need yet another video over IP solution? So hopefully that's something you guys are interested in. We'll start with a little background. If you're not familiar with Nextera, we're a member of the committee that's developing the IPMX specification. It's called VSFTR10 committee. Uh, our mission is to help Pro AV manufacturers add IPMX capabilities to their products quickly and easily. And we've got reference designs you can see anytime you like, but that's a little bit about us. Let's jump into the presentation so you can kind of see what we're talking about here. So let's talk about the AV over IP landscape a little bit first. What we're seeing is a much better demand for interoperability in the Pro AV market. As you probably know, there are a lot of different solutions out there for video over IP, none of which are compatible. So we're seeing some pull from the market that says, we'd like to have this interoperability, just much like if you buy an audio system for home, you want speakers from vendor A and you want a receiver from vendor B, you'd like it all to work together. We're also seeing demand for scalability, ability to expand resolutions, expand frame rates. That's sometimes difficult to do with copper interfaces. You need to go to newer versions, newer speeds. With IP, you get the ability to increase these and just use the same cabling but increase the bandwidth. And you've seen there's some confusion over the available solutions. So that's why we got into this space, to try to solve these problems. What are some of the benefits of AV over IP? You get reach, you can send it all across a facility, you can get much lower infrastructure cost, and the flexibility and scalability. So what's out there today? You've probably seen some of these. There's a SDVOE solution, which works well in many applications. The NDI solutions as well, and Dante are kind of the three big players. The NDI solution is more than just one, unfortunately. They've got HX2, HX3, high bandwidth, a variety of solutions that are out there that add some confusion to the market. They all have their niches, and they work well in certain places. Dante as well, they've got AVA, AVH, all work well in their own niches. But it's very confusing for a customer that's trying to understand all of these and where do they fit and how do we fit in. So we're trying to address this by providing, as opposed to single vendor solutions, which they're fine, they work, but they're not open standards, and they're kind of tied. You're kind of tied to that particular vendor to keep your solution alive. We want to provide a next generation system that is truly interoperable. It's truly an open standard, independent of resolution and network speed, standards-based, again, which is key. The best and brightest minds in the market got together to develop this, to make sure that we've handled all of the issues, we've handled the worst-case scenarios, we've thought about things like packet pacing and interoperability. We're using industry-validated codecs that have been tested through ISO and other organizations, and fully scalable solutions that can meet the needs of the market, anywhere from uncompressed to highly compressed, but with a common transport, a common control system, right? So you don't have all these different islands of things that maybe work well in their own island, but we want something that will work across all these requirements. So that's how we got into this. And that's where AIMS comes in. So AIMS, Alliance for IP Media Solutions, again, a group of industry experts that were trying to come up with a solution to address this problem. And that's the genesis of IPMX, the IP Media Experience. That's a combination of a set of standards that kind of helps you meet these needs. So we'll talk about some of these requirements that we had and how it stacks up compared to some of the existing solutions. I'm not going to go through this entire chart, but there's some things that are very important, like the codec. You'd like to be able to handle multiple codecs, not just a single one, again, depending on your bandwidth requirements. That's incorporated in IPMX. You'd like to have very low latency in Pro AV. Yes, it's codec dependent, but it's very few lines. In the case of uncompressed, it's 2 lines. And in the case of the current solutions that are JPEG XS, it's somewhere in the order of about 16 to 20 lines encode and decode, so very friendly for a Pro AV environment. We were also handling the secure aspect. We have the ability to encrypt the communication through secure NMOS, which is becoming more and more important in facilities. It's available as FPGA cores and software-based products, so a much more flexible solution. Control is built on an open standard. You don't have to rely on a proprietary vendor control system. You can use an industry standard control system that's fully compatible with any of these devices from any vendor. And near visually lossless quality at 1G is kind of one of the driving factors as well. So why do we need an open standard? Why can't we just use a proprietary system? Well, we really want to leverage the industry of the entire industry. There are a bunch of smart people in maybe in a single company, but there's a lot more smart people when you put them together and put their heads together with a lot of experience of what's gone well and what's gone poorly. We can address these up front, and then the customer doesn't have to worry about it. We want to reduce operational expenses, eliminate some of this complexity of integrating multiple systems together. We want, this multi-vendor interoperability. It gives us the plug and play, which is really what the customer wants. It's just like with your PC at home. I don't know if you guys are old enough to remember flipping dip switches on printers to make them connect to your PC. Nobody wants to do that. You just want it to plug in and show up and work. We want to avoid any IP dead ends. What happens if a vendor leaves the market and you're invested in their solution? You're stuck, your customers are stuck. And we want to enable media companies to exploit the performance benefit of these open markets. So what are some of the key technologies? IPMX is not a totally new standard. It's actually built on top of SMPTE 2110, which is the industry standard for the broadcast video market. It's been proven over many years. It's the go-to. All the major networks have adopted it. It's the #1 new solution for new installations. So we didn't say, let's just create a whole new system. Let's build upon this working system in broadcast and just add in some additional features that the Pro AV market needs. So one of the things is compression, and the initial solutions are using JPEG XS. There's other codecs, but that's a key technology that's enabled this 1 gig transport of high quality video. NMOS is a key technology also used in broadcast that allows this plug and play discovery of devices, connection of devices with a simple interface, a very simple control mechanism. And you see there's the SMPTE as well. So where are we with IPMX? It's a kind of a living, breathing specification. It's growing, but I'm pleased to say we've reached a major milestone. We've got the base functions complete. They're published on the VSF website. All these items on the left are done. We've interoped against them last week, actually. A group of manufacturers have tested against the specs. We're happy that everyone's interpreting them the same way. The products are talking to each other. The work does continue. There's other efforts that we're working on, things like USB and wider network things and content encryption. This is development that continues. So there'll be optional features that are added, but the base profiles are here, so IPMX is ready to go. If you're interested in these specs, you can go to the VSF website, vsf.tv. You can see them all. These drafts are going to go away very soon because we've just completed the interop and they're ready to be consumed by the mass market. So one of the key items in here, there's a lot of additions that were added specifically for the Pro AV market, but really I think the key one is the synchronization, this TR10-1. In broadcast, we used a PTP, Precision Time Protocol. That's kind of a network genlock that allows everybody to be synchronous. But in a Pro AV environment, that might not be possible or practical. You might have a PC, for instance, that doesn't have a way of locking to a house sync. So, PTP is great. It gives you this signal alignment. And what we've decided in IPMX is if PTP exists in the system, it's required that the devices respect it. You might as well, right? It's there. It's a synchronous system. If it's not there, we have a way of actually sending timing information from the senders to the receivers, and the receivers can do clock locking and provide that same low latency two-line connection from a sender to receiver, even if PTP is not in the system. We've also relaxed the rules of PTP so that you don't need a fancy PTP generator. A lot of the nodes actually have this built in, and they're able to use it at very low additional cost. One of the next key technologies that makes this attractive is the JPEG XS, which I alluded to earlier. It can give you visually lossless compression at 10:1 compression ratio, which would be like a 2.5 gig interface. At near visually lossless at 14:1, which will fit on a 1 gig interface. So most of the video you're seeing around here is the 1 gig at the near visually lossless. That seems to meet the needs of most of the market. Ultra low latency, small footprint in FPGAs, low cost, which is what this market wants. I've touched on NMOS before. Let me describe how NMOS works, because this really is a key component of this. So NMOS stands for Network Media Open Specification. It was developed by a group called AMWA, Advanced Media Workflow Association. It's an open specification that's published on the website, and its goal in life is to enable 2110 and IPMX equipment to operate seamlessly, much like we did with HDMI cross-point switches and SDI cross-point switches. You really just want to go up and push a button, right? You want to say destination, source, take, like we've done for many years. Well, that's what NMOS does in the IP world. But it adds in the benefit of plug and play. So in an SDI world, you never really knew, is your source turned on? Is there something there? What resolution is it? You don't really know. In an IP world, well, we can send packets back and forth. So all these devices can say, hey, here I am. I'm running at this resolution. I'm this vendor. So you can actually auto-populate things like button panels. So again, improve the user experience. They get their familiar cross-point matrix, but oh, guess what? It detected that this system came on automatically. So now I can route a source to a destination. How exactly does this NMOS thing work? Well, there's an additional component that wasn't available or wasn't required in HDMI or SDI system. It's called this registry. It's just a database. It's a little PC somewhere that has a service running and a simple database. All the NMOS nodes, in this example, a couple cameras and a receiver, as soon as they're powered on, they send their information to the registry. Hey, here I am, I'm a display, I'm this vendor, I can handle these resolutions, I'm a camera, I can support these resolutions. So the registry now has this database immediately after power up. The control panel queries that registry and goes, oh, okay, I see I've got these two senders, I've got this receiver, I'm ready to go. A user can then go punch the buttons in there. Let's say source, the bottom camera is already connected to the display. He wants to switch to the leftmost camera. How does that all work? Well, because you're running through a network switch. You're not running through a cross-point switch. How can you possibly connect it? Well, we use this technology called IGMP, Internet Group Management Protocol, which is built into switches and it's been around for a long time. So the monitor sends a message to say, disconnect me from the multicast stream coming from source 1 and join the multicast group of source 2. So NMOS all does that behind the scenes at the push of a button. So in summary, the Pro AV market needs a high quality solution to enable interoperability. It's got to be efficient, it's got to be secure, it's got to meet the needs of this market. And that's why we created IPMX. It's the only solution that gives beautiful 4K video over 1 gig Ethernet, includes security for controlling content, and leverages all of these existing standards to create a solution that will be around with us for the long term and is proven with tested interoperability so the customer doesn't have to wonder and worry, is it all going to work together? And most importantly, not relying on a single vendor for core technology. That's all I have today.